Hello and welcome. Today we're going to be looking at linear and exponential growth as part of the problem solving and data analysis portion of the SAT math section. As always, we're going to be looking at 5 questions, explaining them to find the intricacies of this topic. And if you like these videos and find them informative, please be sure to like and subscribe. And with that, let's get started on our first question of this topic on linear and exponential growth. So we're given this table of key number and frequency, and we're told that Miguel numbers the 50 keys on his musical keyboard from left to right, starting at 0. The table at left shows the frequency f in hertz of the sound waves emitted when the key number k is pressed for some of the keys. Which of the following equations best models the relationship between the key number and the key frequency? Well, let's see what we can do here. So every 12, right, every more 12 keys, we see that the frequency doubles. It doubles every 12 keys. So that's going to be exponential growth. Right, so we can cross out immediately choices C and D because those aren't exponential growth. Right, those are linear growth. So C and D are out, and we're left with simply A and B. Well, for choice A, after 12 keys, this would suggest that the frequency is going to be 65 times 2 to the 12. Which is way over what we're given. We're just given 64 times 2 to the 1. So that's going to be answer choice B. Since after 12, we get 65.5 times 2 to the 12 over 12, which is 2 to the 1. After 24, we get 2 to the 24 over 12, which is 2 to the 2, times 4, times 8 for the 36, and then times 16 for the 48. That is what we want. So our answer then is going to be choice B. And let's move on to the next question. All right, next question, here it is. The depth of a newly formed river in southern Africa has been monitored every 6 months for the past 4 years. The scatter plot has been shown on the left, and the TD plane shows the measured depths D in feet 2 months after monitoring began. Which of the following equations best models the relationship between D and T? Well, this is going to be linear growth, as you can see, right? This graph grows linearly. Right, in a straight line starting from 10 at 0 and going here. So we're going to have to start at 10 from the beginning. So we can't have A because that's exponential growth. And we can't have D because can't have answer choice C because for answer choice C, D equals 10 times 0.83 to the T, which is also exponential growth. So we're left with B and D. So which one is it? Well, at t equals 0, d equals 10. So which means that's going to be answer choice D. Since t equals 0, that makes 10 plus 0, 10 for D. So our answer then is going to be choice D. And let's move on to the next question. All right, next question. And we can think about this, and instead of, we don't even have to read the answer, or don't even have to read the prompts at this point. We can just think about how we approach this problem. We again have another linear graph pointed down, starting at what looks like 37, 38, right? So we can see 37.5 is given out in here. So it has to be 37 or 35. It can't be these other ones of 68 or because that's not what we're starting at, right? The altitude is not starting at 68. So A and B go away. And then C is exponential growth, which is not what we want. We want linear growth. So we're going to pick answer choice B as our answer. And let's move on to the next question. All right, next question. And let's see what we can do. So we see this time it's not a linear, it's an exponential decay. It's not exponential growth, it's decay, exponential decay. And that's what we have. So at x equals 0, we have 92. Right, so x equals 0, we have 92. We start at 92. That seems to be in all of them, but we can cross out the linear growth ones. And then what do we see? Let's see. Well, with answer choice C, if we left the cup forever, then it would eventually get to 0. And answer choice D, if we let the cup go forever, it eventually get to 22. Which one is it supposed to get to? Well, it's cooling in a 22 degree Celsius room. So it's never going to go below 22 degrees Celsius. It's going to stop at 22 degrees Celsius, which is answer choice D. So that's our answer. Answer choice B. And let's move on to the next question. All right, next question. Here it is. And we're given something that, again, looks to be more of a exponential decay scenario, right? So you can cross out the linear ones, which are C and D. And looking at this, they start at the same value, but one is 1.1 and 0.9. If your factor is greater than 1, so a factor greater than 1, that's going to be growth. A factor is less than 1, it's going to be decay. This is exponential decay as it is going down, which means that our answer has to be the one that's less than 1, which is 0.9, or choice B. And that's our answer. All right, so as you can see on this topic, the main idea is to simply take the graph and think about whether it follows a linear or an exponential pattern, right? Whether it's a straight line or not. And then from there, if it's linear, you can use the initial starting point and the ending point, the x-intercept and the y-intercept to find everything else. And if it's exponential, you find if it's going up or down, if it's growing or decaying, and that's how you find if it's linear exponential growth, and you put equations to the graph. That is it for this topic, and I'll see you next time.